Hello everyone. So before starting with today's video, I would like to ask all of you a question. Which are the most important resources for sustaining life on Earth? So the answers are air, water and food. So today's video is on water. Water acts as a very important resource for all living organisms as it sustains life and even acts as a habitat. And so, life on Earth cannot be sustained without water. Did you all know that 71% of Earth's surface is water and only 29% is land, out of which 99.7% is locked up in oceans, seas, ice caps, and is floating in the air. Only 0.3% of water is fit for drinking, of which most is polluted. Therefore, there is an absolute need for conservation of water. Every day, lots and lots of water is wasted and many extremely harmful pollutants are released into fresh water, making it unfit for drinking and other uses and even degenerating the biodiversity. Millions of people die each year because of not getting enough water or by drinking contaminated water, which causes a great loss of life, and therefore we all should start to conserve water. Researchers have found out that a lot of water is wasted only in household by activities such as not closing the tap or letting the tank to overflow. As rightly said by Tony Farquhar, if you want to change the world, start with yourself first. To start to conserve water, we should start conserving water from our own houses. And this is what today's project is about. So without wasting any further time, let's begin with our project and take a step to conserve water and save our environment. So our today's project is a water tank overflow controller. For this project, I have used a glass filled with water which is acting as a water tank, a water level detection sensor, a passive buzzer, LCD and 3 LEDs. We have already learned LED and LCD in detail. So today, let me introduce you to the water level detection sensor and a passive buzzer. This is how a water level indication sensor looks like. It consists of a series of 10 exposed copper traces, 5 of which are power traces and 5 of which are sense traces. One sense trace, indicated by S, between two power traces, indicated by P, are bridged by water, thus connecting the traces and complete the circuit. The water level detection sensor consists of 3 pins. The signal pin, which should be connected to any analog port on the Arduino board, the positive connection that should be connected to the VCC, and the negative connection that should be connected to the ground. So let's now understand how a water level detection sensor works. The resistance of the water level detection sensor is inversely proportional to the height of water. If the length of the water is more, like in this figure, the conductivity will be more and therefore the resistance will be less. While in this figure, if there is less water, the conductivity will also be less and therefore the resistance will be more. The sensor produces an output voltage according to the resistance, which can be determined by the level of water. In my project, I am using a buzzer module, a passive buzzer module, and usually the active buzzer module and the passive buzzer module look the same, and to differentiate it, it's quite difficult. So these are some notes that I have removed, and it will help us to identify if a buzzer module is active in nature or passive in nature. An active buzzer module can be identified if it is having 8 or 16 volts, and a passive buzzer module can be identified if it is having 2 or 3 volts. The active buzzer module or the active buzzer generates tone using an internal oscillation, while the passive buzzer or the passive buzzer module generates sound like an electromagnetic speaker. Changing input signals changes the sound. Therefore, the active buzzer can only produce one sound, while passive buzzer can produce multiple types of sounds. Like you can even play a song with a passive buzzer. The active buzzer requires a DC current, while the passive buzzer requires AC current. So the main identification feature is the number of volts. This is the code. The entire code will be available in the description box. It says that if the value is greater than or equal to 150 and the value is lesser than or equal to 240, the green LED should be high and the LCD should print water level low. If the value is greater than 240 and lesser than or equal to 290, the yellow LED should be high and the LCD should print water level medium. If the value is greater than 290, the red LED should go high, the buzzer should sound at a note, and the LCD should print water level high, stop water flow. Let me upload the program now. The program has got uploaded. As you can see, the water level sensor is dipped at a certain level in water, and in the LCD you can see water level low and the green light is glowing. Let me add some more water and let's see what the result is. As you can see, the yellow light has turned on and the LCD is printing water level medium. Now let me add some more water and let's see what happens. As you can see, the red LED is on, the buzzer is sounding at a note, and on the LCD, water level high, stop water flow is getting printed.